this session is all about getting you the complete knowledge of how do we write looping structures using MIPS instructions with QTSPIM, and I'm going to show that one by one. We'll go ahead with it. But before that, I want you to understand how do we print the strings in MIPS. I mean using QTSPIM. Yeah, I'm ready to share the screen. Don't worry. First understanding that you need to have is how do we go ahead and how do we print a string. For example, I want to print a string saying this is the final output. How do we do that? That's the first step that we need to understand, and once we learn that, we'll go to the next steps where we will complicate things a little better. Now see that, please understand, we have to use this. This is fundamental. Now I hope you can see the screen. This is fundamental.text. This is the text assembler directive. Now this is again, I'm writing a function and it is global. I can access it from anywhere. Now the main is here. Now what we need to do is we have called the system call called exit system call the last time to exit the functioning. I mean to exit from the code smoothly. I hope you have done that the last time and you have seen the result. But this time what we are going to do is we have got set of other system calls that we are going to use, and those system calls will help us in printing, will help us in do all this housekeeping work. We need to do a lot of housekeeping work and we are going to do that through this available system calls. Now one of those system calls is called the pointer, I mean the print string. We are going to print string, and how do we use it? Very simple. The name of the system call is print string, and I need to load the value 4 in the V0. V0 is the special register, and V0 is where we have loaded the value for exit also. This exit code 10 is used to exit from the current running. The current code will be exited after you load this and then call the system call. Now what are we going to do is we are going to load 4. The 4 when you load, it will print the string whatever is allocated to it, whatever allocated for printing it. That's it. When you load 4, you are prompting your processor or the simulator to print something. But where is it going to print from? What is it going to print? Now for that, we have got something called as LA. You can see that I am loading. LA is an instruction again, but it is not available in most of the MIPS. This is a pseudo instruction here. Now what do we do is there is a special register called A0 which can carry the address. A0 is going to carry the address, and I am going to load the address of the message which I have to print as a string into A0. So this message is available here, and remember all the contents which you want to print, which you want to go as text content will all come under data section. This is all text, this is all data. Whatever you want to print as the content, whatever strings you have, it's a data structure, so it goes inside the data. You need to put dot data, and inside that what is the name of the message? The name of the message is MSG, and I put a double colon, I put a colon here. I use a directory called as ASCII Z assembler directive. ASCII Z assembler directive will help me in assigning memory towards the string that is declared after it within double quotes. You can see that here I have got a double quote and I have got Shriram YouTube something here, and I close the double quote. So Shriram YouTube will be assigned with some memory using that ASCII Z, and that is going inside the data section. Now this message's address will be loaded into A0, and when you call the system call, this message will be printed. And once it is printed, I'll have to exit, and how I exit? I need to load 10 into V0 and I call the system call. So that will be exited. I repeat, whenever you want to print the string using MIPS with QTSPIM, you need to load the corresponding system call for it. The system call for printing strings are already created, and it is called print underscore string. It is represented by the number 4. Load the number 4 into V0, create a message in the data section, give the message address to the A0 register, load it with LA, and that's all. Call the system call, it will be printed. Now what I'm going to do is I'm going to run this through to show you how exactly the output will come for this particular execution. I'm sharing the screen right now. It may take half a minute, so please wait. Until then you will have to wait. There is no option. 1 second. Is the code clear? I hope it is clear. Right, now you can see that I have got the QTSPIM loaded. As usual, please make sure that you go ahead and reinitialize simulator. Right, without reinitializing, do not try anything. It might end up in giving you errors or it could trouble you. So file, I load the file, and where do I have the file? This might not be visible to you because I have not shared the screen. So the file name is string print. I am loading that file right now, and it's loaded. You can see that I have got no registers pulled in here. I have got no registers pulled in. All these registers are set to default and all the values are 0. Now when I run it, I should be getting the output. I got the output, but you will not be able to see it. I'm going to share that screen as well so that you can see that console. You can see that Shriram YouTube is available here, and this is how we print a string using or print a text message using the system call which is already made available to you. That's it. It's a very simple but yet a very important thing to be learned for further processing. I'm going to go through the next one where I'll show you how exactly to use the if loop. I'm going to show how to convert your C program which has got something to do with if into MIPS, and then we will go with VNE and VEQ, which can be used for converting your C program which has got a for loop or which has got a while loop operation in it. And I want you to try it out for the switch case later, which I will give you some resources also. Now is it clear till now? I hope I have made it clear for how do we print a string with the system call which is already available, and you will have to use it. Now let's go ahead and understand what is the problem statement that we need to take right now for analysis. The question in C programming given is, I have got int count equal to 2 and sum equal to 4. If sum is greater than count, I need to do output equal to count by sum. Else, I need to do output equal to count plus sum. That's all. I need to just compare if sum is greater than count. If sum is greater than count, I will do a division. Else, I will do an addition. That's all. Now I use an if construct here followed by the else construct. So how do we do it? Very simple. I'm going to write a code for it and I'll explain you. Now data is not required here, but I have included it. Since it was a copy paste from the previous code, I edited it, I included it, but it is not required here. Now I go with the main where I loaded T0 with 4. This T0 can be treated as count. T1 is loaded with 2 and it can be treated as sum. That's up to you. You can swap it as well. No issues. But now what do we need to do? We need to find out if T0 is greater than T1. I'm telling you, I'm going to compare these two registers content, and how do we do it? BGT, branch if greater than. If it is greater than, what do we do? I need to go for division, else I will go for addition. That's all. It's very simple. So branch if greater than, T0 is compared with T1 and I go for division in case it is greater than that. And now otherwise I'll have to go and do the addition operation. And now exit will load the system call 10 into it. 10 is nothing but it is going to call the system for exiting. Call for exiting, and it will exit smoothly. That's it. This code is very simple. Where I have used BGT, we have got branch if less than, branch if greater than. I will give you that data sheet which will help you in understanding what all the available instructions which can be used towards using the switch case or if else. I want you to try it out yourself and let me know if you have any troubles. Can we run this? I'm going to run this code right now so that you can understand how exactly things work. Now let's understand. We are comparing T0 with T1. So T0 is 4, T1 is 2. So obviously what should happen? It should take the division path and it should give us the divided result. Can we go ahead and run it? That's what I'm going to do right now. And if you cannot see the screen, let me know. I'll figure it out and I'll get you that again. You can see the screen right now, I believe. I am reinitializing the simulator. See that the results will come and sit in the high and low register. Whenever you are doing a division operation, the low will get the quotient, high will get the denominator, and these are the two registers that you need to watch out for. The rest of the registers, the T1 is 0 now, T0 is 0 now, so I have not loaded anything right now. So what we need to do is, we need to load the file. I am going to load the file and the file name is if_mips. I have loaded it. Now everything is empty. Please watch it. Everything is empty. Now I'm going to run it. You can see that T0 is loaded with 4, T1 is loaded with 2, and since it is greater than, since the condition is met, what do we need to do? We need to do a division. 4 divided by 2 is 2. So the quotient is 2. The remainder is nothing, and this is updated. This is how you can use the if else construct using MIPS. Can we test the another condition which is true? I mean which is false. I'm changing the value here. I'm changing the value as 2 and 4. You may not see that, don't worry. I'm changing the T0 as 2 and T1 as 4. Just opposite I have changed it. Let me reinitialize the simulator. Let me load the file. Let me run it. You can see that here. No, I didn't change the value. It did not get reflected, I think. 1 second. So we need to see the values in, so see. 1 second. Reinitializing simulator. I will put some values like T0 should be lesser than T1 right now. So that's what we need to do. So what I'm going to do is T0 is 1 and T1 is 2 or something. Okay, I made it to 1 and 2 I have entered. I can show you the code once I'm back in the screen. I don't want to keep switching the screens. Reinitialize. The problem with this simulator is it is very cranky at times. So you will have to be careful in loading it. So be careful with that. Now the values are empty, T0 and T1. Now the T0 is lesser than T1. You can see that here. The T0 is less than T1. Now the condition should fail and we should get the added result. You can see that here. The result goes to T0 and 2 was added with 1. That's it. So the condition fail is also accommodated clearly. That's it. Now I will share the screen where I made the change in the code so that you can believe the change. That's it. Here is where I have changed it. So this is the way you need to use BGT or branch if less than or something like that. Wherever I have an if else problem, if else condition to be met, you can use this. Now the next one to be understood is very clearly, I will show you how to use the while loop problems or for loop problems. We need to understand how do we categorize the for loop issues and while loop issues. I have to show you both. So let me open it. I have typed the code already. 1 second, I need to open it and then I will show you the code. All these are very interesting. Just try it out. If you have any issues, let me know so that I can always help you. Can you see the screen? Is the screen visible? 1 second, let me complete it. I will answer your question. Wait. Is the screen visible? I hope the screen is visible. I want somebody to acknowledge. Okay. Right. Now, I am going to show you how exactly do we counter the questions which has got the while loop or for loop. Okay. While and for are eventually the same. Do you think there are major differences over there? They are the same, just they are different in the syntaxes. That's it, right? Whichever I am comfortable with, I can use it. I believe while and for are the same way of executing something repeatedly once the condition is met or not met. Okay, that's it. So what I'm going to do is, I'm going to take a scenario here in C program where I have got count equal to 0 and sum equal to 0. And when the count is less than 11, I need to do a sum equal to sum plus count and count equal to count plus 1. What is it? This is nothing but I'm going to add the natural numbers from 0 till 10. That's it. I'll keep it adding and I'll put the result back in some of your variables. So this is the condition. The condition to be checked here is while count less than 11. Similarly, when you go to the for loop, what happens? I'll initialize the count with 0. I'll check if the count is less than n. Then I'll come inside. I'll do the processing. Then I'll go ahead and increment the count. So same is the thing that I do here. Count plus plus happens here. Condition is checked here. The process happens here. That's it. It's very simple. So whenever you are getting a question with for or while, I repeat, with for or while, you can follow the same instruction that I'm going to give you right now. You can just follow the same instruction and that will be sufficient for you to go ahead and get it pulled. I'll answer the doubt questions whatever you have a little later. Wait for now, right? Now let's go ahead and see the code. I'm going to use the while and for loop with the MIPS instructions, and we can use BEQ or BNA as appropriately as you need. And here I chose BEQ. What is it, sir? How does it work? Very simple. I am going to go with the code right now. I am loading T0 with 0. This is nothing but count is set to 0. I am loading T1 with 0. Sum is set to 0. This is called initialization that you do traditionally in your C programming towards calculating the added result. Now I need to go ahead with the code where I have got something called as while loop. So while jump while, I'll keep jumping within this. I'll keep looping within this. This is the while loop and I'll keep looping within this. Remember. Now What is it? Very simple. BEQ $T0, comma 11 exit. What do you mean by that? Branch if equal for T0 with 11. When it touches 11, it has to exit. So I exit here and I have loaded the system call. But I will keep incrementing the value, right? So what do? Add T1, comma T0. T1 is added with T0 and the sum is updated here. Also, the iteration gets incremented here by 1 so that the count can be incremented. Once the count is incremented, I update that value to T0. I'll keep looping it, and when the T0 touches 11, I will exit. Until then, I would have got the value added in this, and I can check the result of T1 so that I'll get the final value. Very simple. This is a very simple way of writing the while loop or for loop. You can use BEQ, BNE, whatever other instructions. Even if you find any interesting instructions which you can go ahead with using it, I am absolutely happy about it. But this is a simple instance where I think you can learn the usage of while and for. What I'm going to do now is I'm going to run this for you so that you can understand how exactly the system works. Let me load the QTSPIM. I have quitted. Some of your machines may get heated up too much if you are using QTSPIM for a longer time. Check it out and let me know. My other machine has a problem. This machine did not have any issues. Whatever I am teaching with you right now is not having any issues, but other machine whatever I have has got a problem, and I avoided using QTSPIM there totally. Now you can see that I am clearing the registers. Now I'll have to load this file. BNE for while is the name of the file. Searching is a pain. Yeah, I will have to name it correctly. I'm sorry, I think I shared the wrong content. 1 second, let me share it right. You are not seeing the QTSPIM screen, right? Yeah, now you should be seeing. Okay, now what I have done is I have loaded that file. Now you can see that what is the code all about? The code is all about getting the sum of first 10 numbers. Now you can see that I do not have anything loaded here, all empty stuff. Let me run it. You can see that T0 has reached 11 and the value is 55. When you add the first 10 numbers, you get 55 out here, and you can try out different logic. This is just a simple example that I typed out yesterday to teach you. If you want different logics to be tried, you can always try that. Now I have got one homework question for you. I want all of you to try it without fail. How do you get the switch case implemented? Take any scenario. I'm not going to force you with do this scenario, do that scenario like that. So I am asking you to try out any scenario for deploying or implementing switch case clearly. I want you to implement switch case clearly and come back to me with the output, and I want that output to be checked. Okay, so I'm going to show you only one more code right now so that you can understand how do we use the QTSPIM most effectively. Just stay for 1 second. I'll just take that code and I'll explain you that. 1 second. I'm going to write an interactive code for adding sum of n natural numbers. The n has to be obtained from the user. I mean, the user has to tell me how many numbers, what is the n value that he needs to proceed with, and I'm going to write code for it, right? Please understand that, and I'm going to show it through QTSPIM, and it is very easy. It is no difficult. But again, remember, I am trying to make it interactive in the sense the user can input the value. It is just like your C programming. That's the beauty of this assembler. You can make it as similar as you can take it up to C programming level. So you will not have any complexity. It's like you can enter with printf and scanf. So we are having something similar to printf and scanf here, and I'm going to use that, and I'll explain you that as well very clearly right now. Go through it, and if you have any queries, I can answer you that as usual. Now remember, the question is very simple. I am going to add the first n natural numbers. The user should be prompted for an input request. Please enter the n value that you want to compute. And then I'll go ahead with the simple looping structure to add the values just like what I did, and I will present the result back on the screen with a text saying that the sum is. That's it. Now, what we need to do is we need to have global main as usual and the text section as usual. But I have got something called as data segment here. As I told you, whenever you are going to print anything, you need to have the content here in this data segment, and you can name that as message 1, message 2, like that, whatever you had in the previous session. I mean the previous example. Let's go ahead with the code. What is the first thing to do? The first thing to do is to print saying that user please enter the input. So what do we do? I need to load the value 4 into V0. I need to go with the message 1, and the message 1 is already made available in the data section, and the message 1 says that please enter input n, and this is all done through carefully with ASCII Z directive, which means that it would have assigned memory for this string inside the data segment, and the memory is allocated for whatever is available within the double quotes. Simple. Now it is assigned. Now what do? I load this value into A0. I call the system call. Once this is done, what will happen is very simple. We have printed something on the console. We have printed something on the screen saying that the user has to enter something. Right. You have printed, sir. Printf is done, but scanf is yet to be done. What do you mean by that? I need to collect value from the user. For collecting value from the user, we have got another system call available like print string that we have used the last time. This time it is called a read int. Remember, it is a read int. Read int is represented by 5. When you load 5 into V0, the integer will be collected from the user and the result will be made available in V0 itself. You can move that result into some other register for your processing. Now what do? This is the section that I am talking about right now. So I loaded 5 into V0. I call the system call. The value is now available in V0. So I moved it to T0. I moved the result to T0 for me to process it. Remember it. Now what do? I need to go ahead with regular processing where I can initialize the counter and the sum. I mean the counter and the sum. The iteration and the sum can be initialized, and I go with the main loop. The loop is just like that last time. So we can keep looping until the condition is met. So add immediate T1 plus 1. This is the iteration, and then I do add sum equal to sum plus I. T2 and T1 are added and the result is updated here. If is compared, I mean while the input is not equal to n, I mean if the input, what is the condition? Until it becomes n, I can now compare branch if equal to exit. So I will keep looping it until it is equal. Now what will happen? What is exit? The exit code is here. So the exit will get a message saying that you are all done with it and the sum can be ready. Sum equal to is ready. In the exit loop, what I print is very simple. I am going to get you the result once my computing is all done. This loop is all done. So I come to exit, and inside exit, I first print the message saying that the message 2 is printed saying that this is your sum. And then I need to print the sum. We did not print the sum, right? So there is something called as print underscore int. These are all the system calls which are available inside. So it's not at all difficult for you to code. Now the print underscore int is available as 1. The code 1 is available, and when you load the code 1 into V0 and you specify whatever is to be printed, it will be moved to A0, and that's all you can print it. Finished. You have it in the A0 now, and then you can print it in the next shot. That's it. It's very easy. So what I do is I print the sum. That's it. I moved it to A0, and A0 is a special register, as you know. Now I have to print a new line. New line is for your comfort. This can be ignored. And then finally I exit it. That's it. That is very simple. Where what I did is very simple. I'm making it interactive. That's all. You can try out different codes with it and let me know if you have any troubles. What I'm going to do is I'm going to show you the output of this right now so that you can understand how exactly things work. I will share that screen right now so that you can see the results. One second. Right. I am clearing the simulator. I am loading the file. The file name is, I forgot the file name. What is the file name? Sum underscore sum of n natural numbers, right? All these are taught and it's already available as a video in the channel. If you have any queries, you can see that as well. If you want to re-listen to it or something like that, you can go with it. Now you can see that the code is loaded. Now what I'm going to do is I'm going to compile right now. I am running it. You would not have seen the screen, so I'm sharing the console screen also right now for you to believe how it works. Now you can see that please enter the number. I am going to enter 9. Sum is 45. That's all. The computation is all done and it has completed its work. So this is called interactive programming, where I interactively collected the value from the user using QTSPIM available system calls and methods. That's it. Now if you have any queries, you can ask me, I'll answer that.